Applications of trigonometry are incredibly important. Trigonometry is one of the most useful mathematics in the outside world that you'll ever learn. The other chapters have applications as well, but trigonometry, historically, we just stop and start teaching you these applications to show you how the math can come alive. So the first word that we really need to understand is something called angle of elevation, and it's the angle that rises from the horizontal. Okay, so keep in mind that this explanation is making something rise from the horizontal up. So let's say you decide to determine how tall a tree is in your front yard, and you stand at the end of a 50-meter shadow from the base of the tree and look up to the top of the tree. Determining that the angle of elevation is 63 degrees. The question is, how tall is the tree? So if we have a tree, right, if we have a tree here, okay, and that tree has a shadow going this way, and that shadow, right, is 50 meters in length. You can easily measure that on the ground. And there are some devices you can use to measure angles, something like an astrolabe. You measure that to be 63 degrees. The question is, how tall is this tree? And when you look at it, you're like, well, okay, that's just opposite over adjacent, right? So this is opposite, this is adjacent, and that just means it's tangent. So we would just come over here and say, well, tangent of 63 degrees is equal to the height of the tree divided by 50 feet that I measured on the ground. And then we would solve this by multiplying by 50. And the height of the tree is going to be 50 times tangent of 63 degrees, which if you take a look at Desmos, that is 98 feet, 98.131 feet. So 93.131 feet tall. So the cool thing about that answer is a mathematical fact. And what's amazing is if you have an angle of elevation of 63 degrees and you measure this shadow correct at 50 meters, that tree is that tall. If you could climb to the top and draw, that's dangerous, right? So that's why measurement at a distance using trigonometry is so useful. So the next concept is angle of depression. And keep in mind that angle of depression is from the horizontal. Students routinely, when I say angle of depression, they routinely draw it here. And this is not, right, this is not the angle of depression. It would actually be this angle. That's the angle of depression. So a person stands on the edge of a 100-foot wide chasm. So there's basically a chasm is like the Grand Canyon. They could have called it the Grand Chasm. So there's a gap basically here. And this gap is 100 feet wide. And they determine the angle of depression from the edge where they are standing to a point at the bottom of the ravine. So I use another word for the word chasm, is 40 degrees. So just keep in mind that they're basically looking down to the bottom here. Just don't put the 40 here. Keep in mind that this 40-degree measurement goes here, okay? And technically this 100, it's actually at the top, but we could also put it at the bottom, right? So that 100 feet that we have, it could go at the top or the bottom. But in this case, why don't we, it just depends on your perspective. So I think based on what we're seeing in this triangle, it probably is better to put it up here, 100 feet. Okay. And so the question is, well, how far is the bottom of this? And again, you're again seeing tangent. Look, opposite over adjacent. So tangent is used so frequently in the real world because the line of sight, which is the hypotenuse, is not measurable easily. So sine of 40 is h over 100. Again, we're going to multiply both sides by 100, just like we did in the other problem with a different number. And using the angle of depression, we're going to determine that the height of the ravine or the depth of the ravine is 100 times tangent of 40 degrees. And so using Desmos, you can easily see that that ravine is 83.909 round up, so 83.910. 83.910. Don't forget your units. This was in feet, so we put a feet here. And the units are really important. Notice I put it on both problems. All right, just remember the angle of depression is inside from the horizontal. It doesn't touch the vertical. So let's say I had a combination of the two, okay? And let's say you're standing directly in front of a tall building and you want to determine its height. Okay, so you walk 50 feet away from it, right? So here's a building like Battlefield High School, right? And you are standing right here, okay? And you decide to walk 50 feet away, and you have an eye level here. So this is 50 feet. And you determine that the eye level to the top of the building is 25 degrees. So that measurement there, that 25 degrees, is the angle of elevation. And then you look to the bottom of the building here, and you see that one, just don't put it in here, that one is 10 degrees. Well, how tall is the building? Well, what you're going to do is, again, you're going to find this height and this height, and you're just going to add them together. So we'll call this height 1, we'll call this height 2. And again, notice we're using tangent because that line of sight, the hypotenuse, we don't know is what it is. So to do this one, we would do opposite over, right, opposite over adjacent. So that's tangent of 10 degrees is equal to the first height divided by 50. So the first height is equal to 50 tan 10 degrees. We do a similar thing for this one. We're going to have 25 degrees though, so tangent of 25 degrees is going to be equal to its opposite, which is h2, or the second height, divided by the adjacent, which is 50 again. So height 2 is equal to 50 tan 25 degrees. We're going to find both of these answers and we're going to add them together. So it's pretty easy to do. You just type them in, make sure it's in degree. Don't do this, because if you do that, the answers are negative and weird. Make sure it's in degree mode. And so 50 tan 10 is 8.816, and 50 tan 25 is 23.15. Keep in mind that those values, they'd be right here, right? So this one, the second one, the taller one, is the 23.311. And the other one is the 8.816. And if I add them together, the entire building is 32.132. So remember, this part's the 8 part, right? And 8 point whatever. And this is the 23. And so to find the total, I would want to add them, which you can see I did right here on Desmos. And so the answer, the sum of these two is 32.136. So to save you some time, I went ahead and filled those out and paused the video. So yeah, this one right here, it came out to 23.315 feet. That's the higher part, not drawn to scale, obviously. The smaller one is 8.816 feet. When I add them together, I get 32.132 feet. I mean, that's incredibly powerful. And we're able to use a simple function like tangent. And sometimes you do have to use sine and cosine. It just depends on what you have. It's just incredibly powerful how easy that is to do and what it can do. You could literally go outside right now and look at a building or a tree and do this problem or this problem or this problem. Just make sure you are careful and make sure you make something called an astrolabe, which you can find plans for that online. You just use a protractor and basically a piece of yarn and a weight, which is really neat that can be done like that.